So far, we have learned how to differentiate a function in order to find its derivative. We can also reverse this process and find the antiderivative of a function. So let's say that you have some function f of x is equal to x squared. If you wanted to find the antiderivative, instead of taking the derivative, you'd kind of do the opposite process. And sometimes you'll see that the antiderivative is like in a textbook or elsewhere, you'll see that it's denoted with a capital F. So, normally what we do is if we have the function f of x, we take the derivative f prime of x, and that's equal to 2x. But if we wanted to go in the opposite direction and find the antiderivative, instead of bringing the power down and decreasing it by 1, what you'd want to do is you'd want to do the opposite. So you would want to add 1 to the power and then divide it by that new power. So 2 plus 1 is 3. So if we did that to get the antiderivative, we would have x cubed over 3. Let's just verify if we took the derivative of capital F of x, which is x cubed over 3, if we took the derivative of that to get lowercase f of x, we'd bring down the power, and we decrease the power by 1. And if we simplify that, that does in fact give us the original function that we dealt with. So again, if you have something like this, in order to find the antiderivative, you would raise the power by 1 and then divide it by that new power. However, something that becomes problematic is if we are talking about the antiderivative, we need to think about adding a constant, because if you were to take the derivative of this now, it would still give us x squared because the derivative of a constant is 0. And so when we're talking about antiderivatives, or later we'll more specifically talk about indefinite integrals, when you're talking about indefinite integrals, this c value here is called the constant of integration. So let's move down here. It says the process of finding an antiderivative is called integration. The function that results when integration takes place is called an indefinite integral, or more simply, an integral. And this is what the notation of an integral looks like. So this is the integral symbol. It looks like an elongated S, and then we have x squared, and then we put dx. And this thing here, anything to the right of the integral sign, is called the integrand, which is what you're taking the integral of. This is the integral symbol. And then this thing here, the dx, that is just to let you know which variable you're taking the derivative with respect to. And it's called a differential. So again, to recap, we would say we are taking the integral of x squared dx, and we would write that this is equal to x cubed over 3 plus c, because we need that constant of integration. So example 1 says, if f prime of x equals 6x cubed, what is f of x? So then f of x would equal, we want to increase the power by 1, and then divide by that new power. And we also don't want to forget our constant of integration. And then we can simplify that to 3/2 x to the 4th. And whenever, plus c, and whenever you are doing these types of problems, it's always really helpful just to make sure that if you did in fact take the derivative again, it gives you what you're looking for. So I would bring down the power, and then if we have a constant, the derivative of the constant is 0. And so let's see, 4 times 3/2 is going to be 12 over 2, which is 6x cubed, which is our original function. So that checks off, and we have found the correct antiderivative here. Example 2 says, if f prime of x is equal to x to the 5th power, what is f of x? So f of x, we are going to increase the power by 1, and then divide by that new power, and then can't forget our constant of integration. And let's just take the derivative to verify. So if I bring the power down, these will cancel out, and it's equal to x to the 5th, which was our original function. So that checks off, and we know that we have integrated that correctly. And if we integrate the constant, then we get 0. So we just have x to the 5th, so that works. So this here, the powers of x formula, just generalizes if you're ever integrating x to some power dx, then the integral is just equal to x to the n plus 1 power divided by that new power plus the constant of integration. And the only thing is you want to make sure that the n value is not equal to 1. And let's talk about why that is really quickly. If we had the integral of x to the negative 1 power dx, if you plugged that into the formula that's right there, you'd have x to the negative 1 plus 1 over negative 1 plus 1 plus c. And the reason that this does not work is because negative 1 plus 1 is equal to 0. So you'd have division by 0, which you can't do. Hopefully you are aware of that by this point. So you'd have x to the 0 over 0 plus c, which is undefined. So this formula works as long as n does not equal negative 1. If it did equal negative 1, if you were wanting to integrate this function, you would have to use a different method that we will see later on in the course.